Okay, so for this lesson, we're going to take a look at determining the validity of a proof or an argument. Now, when we did the deductive reasoning, we showed how we could use algebra to prove that whatever our mathematical process was, it's always going to work out to be true. When we're taking a look at the validity, we have cases of fallacious proof, where it says in math, a fallacy is an incorrect argument in logic and deductive reasoning. One of the most famous fallacious proofs is the attempt at using deductive reasoning to prove that 2 is equal to 1. So, here's the proof that somebody has done. Let A equal B, then A plus A is equal to A plus B, 2A is equal to A plus B, 2A minus 2B is equal to A plus B minus 2B. 2 times A minus B is equal to A minus B. 2 times A minus B over A minus B is equal to A minus B over A minus B. And then 2 times 1 is equal to 1. 2 is equal to 1. So, first thing we're going to do is write down how they got to this process. So, first thing was the setup, A is equal to B. Then they added A to both sides. The next thing that they did was combine like terms. Where they grouped the A's together on the left-hand side. Now, they're subtract two B's from each side. And we can see that here and here. They did a common factor on left side. Where if it was 2A minus 2B, they just divide both parts by 2. Now they divided both sides by A minus B. Once they got here, they factored or divided both of the fractions from the A minus B, which means they factored out or pulled out the common factor of A minus B from the top and bottom, A minus B from the top and bottom, and then on the left hand side, when we divide both of them out, it was just 2 times 1, and on the right hand side, anything divided by itself is just 1, and then they just simplified the left side. So from a distance, it looks like everything they've done on both sides, or everything that they've done is mathematically possible. Now, if I'm saying in which step was there an error in deductive reasoning, well, I'm going to tell you right now, the error in deductive reasoning was in step 6. When you divide both sides by A minus B. The reason for this is in step 1, they said that A was equal to B. Well, if A is equal to B, then A minus B would be the same as A minus A, because they're the same, which would equal 0. You can't divide by A minus B Because it is the same as dividing by 0. And any division by 0 is undefined, so this mathematical process won't work. As soon as we try and divide by 0, it is kaput. Okay, let's take a look at another example. So when we're talking about validity, in math, a proof is valid if the reasoning is true in every step of the proof. We can say the fallacious proof 2 is equal to 1 is invalid because of the steps, namely step 6, where the reasoning doesn't work. It doesn't mathematically reason because we can't divide by 0. Even though all the other steps are correct, it only takes one mistake in the proof for the steps doing one thing that mathematically does not work in order to disprove it. In math, an argument is when two or more statements or propositions called premises are used together to form a conclusion. An argument can be valid or invalid, as in the case of, or as in this coming example, and in the case of number 1. Although the following points regarding arguments are beyond the scope of this curriculum, it may be worthwhile to note the following. Whether the premise of an argument are true or not true depends on the content. The validity or invalidity of an argument is determined by its logical form. This is why, in logic, validity does not necessarily imply truth. An argument can be valid, but not sound. An unsound argument is when the premise of the arguments are not actually true, but lead to a logical conclusion. This is a fancy way of saying I can have two statements that aren't necessarily true, but the idea that they prove actually is something that is true. So even though your argument is illogical, the conclusion you come to in the end is actually true. Alright, let's take a look at these arguments. So concerning the following arguments. For argument 1, all women are mortal. For part 2, Anne Irving Young is a woman. Therefore, Anne Irving Young is mortal. For argument 2, some people who cough have the flu. Jaden has a cough, therefore Jaden has the flu. So first off, which argument has the error in reasoning, and what is the error in reasoning? Well, I mean, it shouldn't be too hard to pick out. The error in reasoning is argument 2. Where did the error in reasoning come from? Well, the first part said some people who cough have the flu. It didn't say that all people who cough automatically have the flu. So we can say just because some people who cough have the flu, that does not mean that all people who cough have the flu. And we already know that there's many reasons why people would potentially cough, so we can't say definitively Jaden has the flu. All right. The last one is one of the most famous logical reasoning examples that exists. So, if we're reading through this, three friends purchase a package deal to the San Diego Comic-Con convention. The package deal includes a ticket to SDCC and a room and board during the convention only. The three friends travel together by car from Lethbridge to San Diego and arrive a day before the convention is to start, late at night, and consequently need one more night stay at the hotel not included in the package deal. They arrive at night and are very tired. The hotel has one room left, but is still under renovation. The manager gives them a discounted rate since the room is not completed and they are attending STCC. The manager charges them $30. The three friends contribute $10 each. The next morning, the manager rethinks the rate and decides to give them a further discount in hopes that they book the room again for next year's San Diego Comic-Con. The manager gives the bellboy $5 to take to the room and give back to the three friends. The devious bellboy realizes the three friends are not expecting any sort of refund and feels it will be too difficult for the three friends to split $5 equally. He decides to give them back only $3 and keeps $2 for himself. He gives the friends the $3 refund. Each friend takes $1. The three friends had originally paid $10, but each of them received $1 back. Now they have only paid $9 each for the room. They are happy the manager has given them a further discount and will come back to the same hotel next year. And the bellboy is happy as well, as he has $2 extra in his pocket. Bill, a student, reads the above story and he calculates the total cost of the room should now be $9 per person times 3 people plus the extra $2 the bellboy kept, which is going to equal $29. Why is it that it's now $29 instead of the $30 that they originally paid? So, this is a classic example of misdirecting the reader. Bill incorrectly calculates the total cost of the room to be $27 plus the $2 the bellboy kept, but this is a meaningless calculation and a distraction from the correct one. The correct calculation is a total of $27, including the $2 the bellboy pocketed as a refund. If we take a look at it and said that it was $30 was what they paid, and they each got $1 back, then that's going to be a total of $27. At the same rate, the manager said that the room was only going to cost $25. So that $27 minus the $2 the bellboy kept is going to be the $25 the room actually cost. So the $2 the bellboy kept should have been included in that $27 that they actually paid. So, what was the error in Bill's reasoning? The money the bellboy kept was included in the $27 paid. All right, get some practice and let me know if you have questions.